So, okay, we are now on this second section that we're going to be talking about setup. Hi, Fiona. The idea or the objective is to fork and clone the tidyds repository. We dedicated several meetups to that, but there is one, the last one, that we compared setups. With that, I want to say that we are going to be aiming for this kind of setup today. That doesn't mean that that's the only one. There is a great discussion with great input from Alex yesterday about a simpler setup. I mean, really, you can use it today if you want to. But I want to, maybe as a way to kind of play with this. We're going to implement this setup and see, how it works, what it means. I think it looks a lot more complex than it actually is once everything is correctly set up. So, as I said before, the goal is to fork and clone this repo, and now I see, in the tidyds organization, in the tidyds repository, there is a forks link, and I see Laura has forked, Jakob has forked, Freddy has forked. Who is this other username? So do we need? So the thing is this. You can totally follow along and not work with Git or GitHub. For the organization, for 2 degrees, I hope that everyone becomes fluent in Git and GitHub, at least via the tools that I'm going to demonstrate through this workshop that are very high level and abstract all the details. So it's pretty, it's not very different to the experience of using any other software. Git can be intimidating, I acknowledge that, and a lot of people don't need it for their day-to-day work. So if that's you, you're feel free to not do this setup and to not fork this repo and to not work with Git. It's totally up to you. You will get a lot less from this workshop. And if you do, you are going to repeat it so many times that by the time the workshop ends, I'm hoping that you will feel certainly confident to contribute to this investing organization, right? With your comments, with your code. Sometimes it can be just something as simple as to fix a typo, and that is a contribution that you need to do sometimes through Git and GitHub. So with that, I open the room a moment for to answer this question. Do we need to? Anyone here, has not set things up and would like to work on the workshop with that? I did reserve time for that, but if everyone is already done, I'm not going to waste your time probably. Perfect. And now the even more important question. The goal or the recommended environment to work today during the workshop is RStudio Cloud, and that is, talking about opinions, it's my opinion about how we can make the workshop fluid, because it provides the exact same environment for everyone. But of course you're welcome to use your own RStudio setup locally. The issue is that anything that it happens differently in your computer compared to what we're showing here, I'm not going to be able to do much about it, because there's not going to be time to debug specific people's computers, right? So instead, I prefer to give everyone the same R environment. And at the same time, because it's an amazing tool that, in the same way that I am using for teaching, I use it for work too. It may inspire you to use it as well. That means that you can use all the tools that we're going to be talking about, and you don't even need to have them installed on your computer, which is pretty cool. So So the question is, do we? Who has? I'm assuming that you're working with RStudio Cloud. Is anyone here working with a different environment? No. Okay. Cool. And the experience went. How hard was it to set it up? Following the instructions that I gave, just as a way to learn how to improve those instructions. It worked. Okay, cool. Okay, so then the next step. So I'm gonna be working on here on the right. I'm gonna close actually the Readme file for a moment. I'm gonna refresh this page. Oh, interesting. Apparently I don't have access to my own thing. Let's see. The beauties of working live. Let's see. Let's go again. You know, I want to work with it from a different account to the one that has all the privileges to do stuff on GitHub, because I want to experience the experience of a user, like in this case of a contributor like you. So here on the left, I'm working on my usual account, the one that has connections to GitHub, everything, or it has privileges, for example, to merge commits into 2 degrees investing. And here on the right, I'm just a plain user. I'm using a different account, as you can tell by the icon. It's a different user. So with this, I should experience exactly what you are experiencing. I shouldn't have on this RStudio session any more powers than you have. So let's see how that works. So I'm gonna close for now this thing, and I'm gonna present you to the way I envision the workshop to go. So here on the right, I have my RStudio, and the other half, I am following on the instructions to know what I want to show you. But that space, you could instead overlay your own half of the screen. And it should be generally enough, because usually in RStudio is very nicely divided in 2 halves, kind of. And we are going to be working with rmarkdown documents that with one half you should have more than enough. So the very first thing I'm going to do is to update the packages. And for that, RStudio gives a nice interface. There is a packages tab, and click here in update. That is a nice habit to develop, because although R itself may kind of change relatively slow, the packages change very fast, and the assumption is that you are kind of up to date. So by clicking there regularly, maybe once a week or once a day or once a month, I know, but don't do it at once a year, because maybe you will be experiencing a lot of problems that come from the installations. So from all installations, and when you don't want to touch your own environment locally, you can use RStudio Cloud, because whatever you install there stays there. It doesn't kind of bother in your computer. And here, notice that RStudio Cloud gives you different versions of R, right? So I'm using the latest one, and I have just updated my packages. So I'm kind of as current as I can be. Also, the setup that I showed in previous videos does not include all the packages. You may need to install these packages that I show here that are friends of the tidyverse. The setup that I showed before does install the tidyverse. Actually, I'm going to install it here too. So with that command, you will be installing all these packages at once. And one really nice thing that RStudio included recently is the ability to install, the default on RStudio Cloud that the packages will be installed from what's called a compiled version, which only means for you, what's important for you, it means that they're going to install way faster than they used to like a month ago, or like 2 months ago. So that is, if you experience that installing packages was pretty slow some time ago on RStudio Cloud, now that experience should have changed and it should be much faster. So also you will notice that when you are on an rmarkdown file, if you don't have installed a package that the file refers to, RStudio prompts you to install it, and you can just click there and it should just work. And then the next thing, so we have updated, we are using the latest version of R. We have updated packages. We have installed the packages that we need. In that order. So it's important. So if you're going to install packages, sometimes some packages may fail to install if you are not current. It's not that you always have to, but it is, if you can, why not? Then you update packages first, then you install new stuff, and maybe depending on, especially if you're in Windows, you may want to restart your R session. And you will see me pressing a lot of keyboard shortcuts. I press Shift Ctrl F10, and you have to be friends with that keyboard shortcut or come here very often to Session Restart R, and that will also remind you of the keyboard shortcut, because restarting the R session is the assumption. So any analysis in R assumes that you start from a clean R environment, because it could be that previous work that you've done is contaminating your current work. So the assumption is that you restart your session often. So that's another habit I would like to kind of spread in the organization. The next thing that I would like to do is to update or synchronize your local computer, your RStudio cloud environment with any changes that might have happened upstream. So remember that figure that I showed you before. So this is you now on RStudio.cloud, and the upstream project might have changed in the last second, whatever. So what we want to do is to, if you did the setup that I showed in the videos, then you will have something like this. You will have in your profile, you will have this thing here, this line, which makes DevTools available all the time. And making DevTools available all the time means that you also have usethis available all the time. And some of the functions that we're going to be using today for working with Git and GitHub come from the usethis package. If you didn't do that, then you will need to do library usethis, and that will produce the same effect. Basically, it means that you can now run a command like this one, pr pull upstream, which comes from the usethis package. So the usethis package is one of the many packages in R. I mentioned the idea of packages before, and this particular command, what does is pulls any change that might be here in the upstream repo. It brings it to your local repository. So now we are up to date. So let's see what's next here. Well, this link here should take us to the Readme file. So the Readme file of the tidyds repository includes now some instructions. You might have read this before to set things up. And there is also these bullet points at the end that express kind of how you can work with usethis. So this is like a high-level introduction first, and then I'm going to demonstrate that in the first lesson, and then we're going to be using that approach all the time. So this first line is what I've just done, and generally you don't need to do it if you did the setup that I showed before, where your very special file called rprofile has a call to use DevTools. So every time you will have usethis available to you. So when you start work on any project, the approach is to start with the function pr_init, which initializes a pull request. In Git jargon, it creates a new branch, and then you start creating snapshots in a parallel world, in a parallel reality, and then those snapshots you send to the source of truth as a proposition in what's called a pull request. And then someone will review it and eventually accept or reject or change those propositions. When you want to pause your work and start working on something else, you can use the function prpause, which basically all it does is changes from that branch of your project, goes back to the main line of development called master, and at the same time checks again that that line of development is synchronized with the upstream changes, so that every time you are, you have the latest changes. So I'm gonna do that. I'm gonna do pr_init. You may want to follow along, and I'm gonna do setup is the name of this branch that I've just created. Usethis responds with instructions. It says that the next thing I want to do is to run pr push to create a pull request if you want to do so. But I'm going to now expand a little this other side to show you the Git panel. And now you can see how this section has a setup name, right? So that is the branch that we have just created. So you can think of it as the pull request to be, right? So we have just initialized the pull request. We haven't yet submitted, like no one other than us knows that it exists, but it's ready to go. And if I want to switch from one branch to the other, you can do it from the menu here. But in the usethis framework, what you can do is PR pause, right? So PR pause, one of the very important things that it does is that not only changes branches, but it also pulls any change from the upstream repository, right? So always make sure that you have the latest changes. So that's one of the beauties of using the usethis package to interact with Git, is because it is very easy to forget. It is easy to remember to change a branch, but easy to forget to update, for example, your master branch locally with a master branch on the upstream repository. So usethis as that for you. You just need to remember these commands here, or remember or come back to this document. And then when you are on a branch, so going back to this menu, if you want to continue working your branch, you can click here and click on the new branch. And then we will be using another function I'm not going to demonstrate now because we have nothing to synchronize, but the function is called PR sync. What it will do is will update a branch. So once you are working on a pull request and that pull request is being also evaluated by other people, it is possible that people will contribute to that pull request. So they might add some snapshots to your own collection of snapshots even before that is merged into the main source of truth. And the function PR sync is going to be very useful for that. I'm hoping to demonstrate that. So that's the high level of how we work with usethis, and again, my proposition of how you might want to work with Git. There's other ways. You may want to interact with it from the terminal directly, or you may want to interact with it from a specific dedicated Git client, like Git Kraken or even GitHub Desktop, I think it's called. So there's a bunch of ways in which you can interact with Git. But for those who work with R, I strongly recommend the usethis package, and I use it a lot because it is so easy. That's so much for you. You have to not think about these details that are easy to forget. So next thing is how to work on each task. So the rest of the workshop is going to be more interactive, very interactive actually. And the idea is that you will be opening like a file, and you will start working with that file, and then submitting a pull request with your advancements on that file. So the idea is that we practice many times throughout the workshop. And we have opportunities to ask questions and to kind of fix broken mental models and things like that by doing, right? More than just me kind of saying. So the workflow is something like this. So the first thing we do is we initialize a pull request with some prefix that refers to the lesson and then your name. So that is kind of easy to keep track of. So the next file we're going to be working with, I'm going to be looking for inspiration for a prefix. So that all files that we're going to be working with exist in the R folder because they are all related to R. The file is going to be called skateboard and then your name. So I'm going to choose the prefix skateboard there then. So I'm going to initialize PR init. So what I'm doing now is creating a branch to work on this file, right? So the branch is going to be called skateboard, or maybe 01 if you want. And then I'm going to do underscore and my name. I mean, you could choose any name for the branch for the pull request, but it is useful that it expresses what it is about. You can use minus or you can use underscore. So I'm going to use the name of the task, and the task is going to be to do a data science task on a skateboard, like a small data science, useful, it's fun, but just a tiny little bit that gives us a flavor for what data science looks like. So I ran that command, and that created a branch as I expected, and here it is. So you can see the branch there, right? So that's step number one. Always start creating a new branch. Do not work from the main development branch, the master branch. Step two, for this workshop, we are going to copy the file that we want to work with. We are not going to rename it, we are going to copy it. And the reason is to avoid conflicts. So what I'm going to do is, there is more wheel here, and you can click there in copy. And the name that you're going to give it is, again, a prefix. So the prefix is fine, as it is. I just remove the copy off part because I don't care about that. But 01 skateboard is fine. But what I want here is, I want to change the name with my name, right? And I click OK. So what that will do is, in the Git pane, you will notice that Git tells you that it has noticed that there is a new file in what's called your working tree. It's in your directory, in your folder, that Git didn't know anything about before. That is why it shows a question mark. So, okay, Git is saying, look, you're asking me to keep track of things, but I have no idea what this file is about. So we are gonna address that in a moment. So if you want to tell Git, okay, this file is meaningful, I want to include it in my pull request, I want to send it to GitHub as a snapshot, then you need to start keeping track of it. So how do you do all of that? You just click that little box there, and you see that the icon changed from question mark, which meant that it didn't know about it. It changes to an A that stands for add. So now you have added this file, and now I'm asking you to imagine something. So imagine that you go to the theater and there is a stage, and there is actresses and actors on the stage doing stuff. Okay, you are putting your file on the stage. So that is the stage where you're gonna be, boom, taking pictures of what's happening, what's the actions that are happening on stage, right? So add means added to the stage, added to the staging area. We haven't yet completed the process of creating the snapshot. We haven't yet taken the picture. We only see the actresses and the actors on the stage, but we haven't yet taken the snapshot, right? So to take the snapshot, you create what's called a commit. So you hit there on the bottom, commit. I'm gonna move this to the right. And that should open an interface that repeats this in tiny. So you would see the file they have just added to the staging area. You would see in green everything that is in that file, and if you have changed something and removed something, it would appear in red. And here you have a compulsory field called commit message. You have to type something there, because otherwise you cannot take the picture. Basically, it is like imagine you have an old, you have a modern camera, digital camera. You want to take a picture without a card, in your camera. So you need to just put something in there. So usually that's an informative message that expresses what you're trying to do. So I'm saying like add new file, something like skateboard, and that's enough. Generally, you can see how there is characters count here. The recommendation, this is probably too picky. The recommendation is to not go over 50 characters because that appears on GitHub overflowing. And generally you don't end with a period there. This is like the heading of, or like the title of an email. And if you want to express anything else, you generally create a space first, and then this is a small data science task, period. So this is the format of a commit message. The first is the subject line of an email. Second line is an empty space, which breaks you jump from basically in your head, jump from your subject line to the actual email. And finally you have, the email itself. So that is all you need to do. And then you can click on commit. and that will actually create that snapshot. You can now close this window, and I wonder, sometimes I wonder why it doesn't gonna go away after some time. It gives you some information. Generally, you don't need to know a lot about that if it works, and if it doesn't work, then you need to read to see what's going on. But you can just close that. And in my case, I'm going to also close the entire window interface. And then we go to the next step, which is to push that change. So remember, we have just created a snapshot of our work. I'm going to click here on the this clock thing on the Git pane is the history. So you can see that at the very top, there's all these things are, these snapshots that have been taken in the past. But this one here at the very top is the snapshot that I have just created. And it is pointing, it has a label, and that label is the name of the branch that I'm standing on, right? So that branch is going to soon become what's called a pull request, a vehicle for my changes. So that change that I've just done, I'm going to use that branch as a vehicle to submit a pull request. And how do I do that? I'm going to first close here. You do that with the guidelines that usethis gave you. So you just run the function prpush, which is also the next instruction here, number 3. So with that, we have just initialized the pull request. Even if we haven't actually changed anything in that document or added any meaningful change there, we can still start the conversation with those that are reviewing or maintaining the repository you want to contribute to. That will open an interface that looks like this, where you have the name of the branch, where that is the vehicle for those changes, for those snapshots. The changes that you want to make live there, and live in this setup. They live in your user account. That's why there should be your username here. And you want to send them as a proposition, as a pull request, to be included in the mainstream line of work, which is called the master branch of the repository that has the same name on the organization, in this case, 2 Degrees Investing. So this is the main source of truth. Here to the left and here to the right is your proposition, and you want to follow this path from right to left, right? So that is where your changes, the path that your changes are going to follow. You just click the create pull request, and I'm asking you to follow along because I would like to see all your pull requests there, and then I will be able to kind of review them and make comments and show you what it actually looks like to work with these tools. So I'm going to create the pull request. As you can see, there is a message there that came from my commit message. So that kind of email that I wrote in my window on RStudio became this. The subject line became the subject line of the pull request, and the email part, the body of the email, became the comment of the pull request. So all of that has just, which I have just made. So so long, I see only, let's see. Okay, I see Freddy has already submitted his pull request, and it would be great if you can work on that. So in the meantime, I'm going to give some time for people to catch up and try to reproduce what I've done. Let's do that in, say, a couple of minutes, and also let's give 2 minutes for that. And in the meantime, I'm very open to hear your questions. Mm-hmm. Mm-hmm. Okay, what you need to do is to first run the so what's happening there, I'm going to clean my console here with Control L, that cleans everything up. So if you go to the Git pane, you should notice that you are not in something that says master, but something that says the name of a branch, probably a branch that you were experimenting with. Is that correct? Okay, cool. So what you need to do is to first go to the, go back to the master branch. So run the command prpause and see what happens. It should change from your branch to master. Please do that and confirm. Yes. Perfect. Can you run prpause and confirm that you were able to change to master? Sometimes you need to refresh. So if you run prpause and you still here see the test branch, then you can refresh with this little arrow. And the other way would be to just click here and click on master. Mm-hmm. Perfect. So now run the function prinit again. And in your case, it would be something like skate Laura, something like that. Run that and see if that works. Perfect. So now your next thing would be to go to the R folder. Well, the issue was, good. Let me wrap up then what was going on. So when you create a new branch, a new PR, you always need to start from master. That's the thing. And the way you return to master is with prpause. So that also means that you can work on many pull requests at the same time. So thank you for bringing this up, because that's a very important question. So sometimes, you're working with, 3, 10, whatever things at the same time. So you switch from one PR to the other. So you may need to start one PR before the previous ones have been merged, so have been reviewed or anything. And the way you create a new branch is always going back to master with prpause and then initializing a new PR with prinit. If you are a fluent Git person and you don't like use this, then in your head you could translate all of that to Git commands, which I'm not going to be covering in this workshop, but maybe later in the DS incubators we can talk about how to do all this kind of the hardcore way. But I don't think it's a very good idea for data scientists in general, unless you really want that. Okay, so then for you, Laura, the next step would be to go to the R folder, find the skateboard file. Click on that box, then on more, and copy. And then you create a copy that instead of saying you has your name. And always copy the rmarkdown version, the one that is .rmd, not the MD. The MD is a product, is the output. Yeah? Okay, so I'm going to click on the file skateboard, my name now. Sorry. Yes. So the way we're going to be working is, okay, so now I have a file that I want to work with, and that file has my name, right? So that's the idea, so that you can submit your pull requests and they won't interfere with someone else's pull request. So if you're working on the same file name, Git will get confused. It won't know if it should track the changes made by Laura or the changes made by me, right? So we need to work with files with a different name. Of course, in real life, you want to work in the same file more than one people, but that's but there is ways to go to work around that, and it might create conflicts that I don't want to be kind of talking about today. So the way we're going to be working is like every time you will see that the files have different, so they all start with this line that say collapse all chunks with Alt-O or Alt-Option-O. That's depending on if you're on a Windows computer or Linux, or if you're on a Mac. So I'm going to do that. I'm going to press Alt and O in my computer. I'm on a Linux system. So see that now all these code chunks. Remember I told you that rmarkdown has the ability to mix prose and chunks. So the chunks have been collapsed. So by doing so, what you have done is you have hidden from your eyeballs the solutions to the tasks. And then it's totally up to you to decide, okay, I'm going to expand by clicking on any one chunk and see it like a little degraded code of what I should be doing. Or, if you want to just go for the solution, you click there. So always for each kind of challenge, there is like a version that is suffixed with -1 and a version that is suffixed with -2. The one that is suffixed with -1 contains the graded code, and the one that is suffixed with -2 contains the actual code. And the way we're going to be working with is, I'm going to be basically filling these gaps, giving you time to type that yourself, and giving you the opportunity to ask questions live. Also, the very cool feature of Git is that you can knit, which means create a report that takes this prose and this code and shows the output. So you can click this button knit and go ahead and do it if you can follow along. So that should produce an output that looks like this one here. So once you press that button, right, you will see something that looks like that, where the chunk that showed the degraded code appears there, and the chunk that has a solution does not appear. That way you can use this output also to guide your task and see if you can fill these gaps and make the code produce the output that you see here on the screen, right? So when you start with every exercise, you may want to start producing the report. You will have that report here, there on the right, and see, see my work or see the document and see whichever of the two kind of helps you accomplish the challenge. And then, okay, so now I am, remember, on a branch. I already started a pull request, and I could have started with this document. For example, the first thing I want to do here is to use the package tidyverse and the package here. So what I could do here is I could type tidyverse, and notice how even when I start typing, I already get some recommendations. So I use that a lot because that should pop up automatically. But then instead of continue typing, I may continue typing until I'm able to disambiguate the options and find the one that I want, and then press tab. That what does is saves me time of typing and also saves me mistakes, right? So I could be committing lots of typos and things like that. So tab completion is a very powerful feature, and I encourage you to use it. It will make you a faster typer and more accurate typer. So that's what I needed to do to complete this line 19. And here in line 20, I want to type library, and same thing, library. Okay, so I typed 4 keystrokes and now tab, and that completes that. So if I now save this file, I could click here on save, or I could also use the keyboard shortcut Ctrl+S. You will see that on the Git pane, you already have a file that Git was already tracking because you added that to the previous commit. Now appears with an M, meaning it has been modified. And then you also have a couple of other files that they didn't know about, which are the output, the MD version of this file, and a file that contains images and so on. So the details are not very important now. All we want to do is to ask Git to put all of those files on the stage, and we are going to take a picture. How do we take that picture, that snapshot? With the commit. So I'm going to create a commit for just this one challenge, which was to complete, how to load packages. But then there is a few other things that we need to do, and that's fine. Commit messages, each snapshot can be very small. Could be as small as 1 character, right? So I'm going to do just that to kind of encourage you to create commits very frequently, many times a day. And the commit is going to be use the tidivers and here. So which are the names of the packages. So I create that commit, I close that thing, and now, although you do have the buttons to push and pull, one use this way to do that would be to the function PR push that you learned before. And that is clever because it will also make sure that your pull request contains any potential change that has been added to the upstream repository. So they use these helpers, use these helpers help you. We're 10 minutes to the end of this block. The next thing I wanted to show you is this other command called prsync. So prsync, what it is, something similar to prpush, but does a little bit more. One thing that it also does here is gives you an URL that you can use to go to the pull request, or you can also run the command prview, and that will send you to your pull request. So now my pull request should have 2 commits, and effectively they are here. Remember the first one where I added the new file, SKATEBOARD, and if I expand here, I should be able to read the message that I wrote, the body of the email. And I took care of not making this message too long, otherwise it would kind of be truncated. And then the second commit where I add the packages tidivers and here in files, the files changed, you see what has changed. So you can see very nicely that the files that you have added, right? Okay, so I'm going to close this for now. I'm going to close this too. Actually, no, I want to have a look to see how many PRs we have now. Okay, we have a lot of PRs. Excellent. Nice. Very, very good. Congratulations. So that is all I wanted to... Actually, no, we have 5 more minutes. So I'm going to be walking through the rest of this document here. And for that, I'm going to now swap the size of the screen. So sorry for that. I'm going to put the output here on the right now. So this is more or less how the rest of the workshop will be. So I'm going to be, having my output here on the right. So I kind of know, what the task is, and I can read these pros, and it's also repeated here to the left. So for you, you could use now the right-hand side of the screen for your rmarkdown document and follow along. So I already completed this challenge, and now let's use the remaining 5 minutes to advance on this document. So you are about to start your data analysis data, your data analysis, and you want to read some data, right? However, this line of code, which looks like it should work because it calls the function readr, which reads data. In particular, it reads, the function reads CSV. It reads CSV files. It looks like it should work. It's referring to data, to the data folder and a file called CSV. So let's look for that here on the project. There is a data folder and there is a CSV. So it looks like it should work. However, this path in particular, when we are working with GitHub documents, isn't safe. And the reason why it's unsafe is going to be clear in a moment. So if you can run chunks of code by clicking on this play button. This will run this particular chunk. You can run this all chunks above this one, and that's important so that everything that happened before is available to be used in this particular chunk. You can use this other button here. So with this button, I run everything from the top to the current point. And now I'm going to run this chunk with the play button here. So notice that this chunk doesn't run. It throws an error. It says that the current file doesn't exist in the working directory, so in the current working directory. And the reason is because rmarkdown have a special notion of what a working directory is. In general, most frameworks understand a working directory as the directory that is at the root of your project. So in this case, it is defined by this file that I mentioned before that is called .rproj. So this file here defines in general the working directory. However, rmarkdown documents by default have a different notion, and the working directory as it is defined by default on an rmarkdown document is the directory where the file lives. So in this case, this file lives inside R. So this file thinks that the working directory is the R folder. You can change that from here, from this button here. There is a button that says Neat Directory. So you can change that from document directory to project directory. I'm going to do that in a moment. But instead, it is better to change that from here. Just by using the backslash here, you are forcing this rmarkdown document to redefine the working directory as it is more normal in R. That is where the root of your project is. That is where the r.proj file is. So now your task is to change line 32 to include a call to here. So you wrap this path in here, and then when you run that, it should work. What it has just done, it just has read that data from inside this file here. So let's move to the next item. So by the way, this is how you could explore a little bit when you print. This is actually a data frame. As you can see, it's like a spreadsheet-like data structure that has columns and rows. If there is more columns that you can fit, you can click the arrow and explore them to the right. And you can close this if you don't want to see it with that little arrow there. I'm going to leave it there because it's a record of what I have just run. And this is a little explanation. This is already done for you. The here package, you can define a path, as I said before, inside here with the syntax, directory / file. But it is even safer to completely avoid the slash, and you can do that instead with this other syntax, where instead of using the backslash, you just separate each component of the path with a comma. So that is the syntax that you will see me typing throughout the workshop, and the one that I recommend because that is completely platform independent. Windows uses backslashes in one direction, Macs and Linuxes uses backslashes in another direction, so it's better to just not use backslashes at all, and here we'll figure out what that path is. So if you now run this chunk, if you give play in line 42, now what you have just done is you have assigned the result of this command to this what's called object or variable called path. That means that you can now type here on the console path, and what it should return is the same thing that you would get if you highlight this code and you run that on the console, right? So if I paste this code here, I get the same result, right? Because this is an operator, and with this I explained that I'm walking through our syntax. For those who are not familiar in R, we use this arrow kind of thing, which is the greater than symbol followed by the minus symbol and two spaces around. We use that to assign one value to the right to a variable to the left, right? So now the path is already available in my environment. So if you click on the tab environment, you can see that now R knows of this path value or variable, and this is the result. So with that, I'm going to break for 10 minutes, and we meet again here at the top of the hour to continue talking about a little bit of R syntax, as we walk through this first example of a data science challenge. Okay, see you in 10 minutes. So while you were refreshing, I hope. I reviewed your pull requests, so I congratulate you for you have submitted a bunch of pull requests, and I went through each of your pull requests. I went to the file changed tab, and I added comments, right? So by clicking on a particular line, I can comment on that particular line, and that's very powerful. And in particular, in the conversation tab of the pull request, you will now see not only your commits as you did them, but also you will see that whatever I highlighted and the comments that I added are there. So we are starting a conversation. So that's why a pull request is so useful, because even before you start doing anything, as soon as you create a pull request, we can start a discussion of what to do, what not to do. So everyone should have a message like this, where I'm suggesting you to add one line that adds the author argument to the file. So I'm going to show you what it looks like, and then you can do it. And then once that's done, I'm going to complete this conversation. It is similar to how, for example, Google Docs work, where you have a conversation. When it's done, you can resolve the conversation. So let me show you what you could do. So at the very top, think that the lesson we are working on now, the goal is to do a tiny data science problem, but mostly it is to introduce you to what it is a GitHub document, to what it is the syntax of R, what it is the preferred syntax of the tidyverse, and a few other things. So this is kind of more about how we do things, more than what we are doing. So at the very top, you will find these two lines, the title of the document and the output format, meaning that when you knit this file, when you click that button, what you get here at the very top comes from here, from the title, and this is what it's telling that it should render in this particular way. What happens if you now add a line, author, column, Mauro? I save that file and I knit. I can also run the knit command with Shift Control K. And that it didn't do what I thought it would do. I think that the GitHub document probably is, so the GitHub document is a bit vanilla, but if I do HTML, you don't need to do this, by the way. I'm gonna change the format. Maybe. Okay. Okay. I misspelled author. Is that correct now? Okay, there we go. So what I'm asking everyone to do is to add this change, to add the author with your name. The reason why I'm doing that is just to practice the idea of reviewing and working collaboratively on a pull request, right? So you submitted a pull request. I noticed it was great. I suggested something that could improve it, right? And I did that on the interface of the pull request itself, which is a conversation like an email, right? Now you go back to our studio, you do the change that I suggested, you save that file, you render the document again to generate the corresponding MD markdown file. And then you go to Git and do the thing of committing, right? So you highlight the files that you want to commit, you click the box to add them to the staging area because you're about to take a snapshot. Then you hit the button commit and you add a little message, something like add author, you commit, and then you can close that window. And in the R console, if you're using usethis, you can type PR push as usual, right? And that will update the pull request. Okay, so I'm gonna give a couple of minutes to do that. Mostly I wanted to demonstrate the idea of reviewing a pull request, so how useful it can be to have a conversation about code or prose, whatever that you're sharing on GitHub. So I'm not going to spend a lot of time, so I'm going to give you just a couple of minutes for you to try that out and to give you also the opportunity to ask questions. So the room is open for your questions right now if you want. push. Did you add? Mm-hmm. Right. Let's see. Make sure that, I mean, that is a common error. It comes from, say, 1 plus a or whatever, right? But it doesn't tell us much because it's such a generic error that it's not useful. So let's try to kind of walk through the process. So you do the change, you save the file, then you create a commit, right? You create a commit. You did. Cool. Do you see anything in the Git staging area? Is everything kind of clean? Nothing all white there? Yeah. And then you did PR push, parentheses, parentheses with no argument inside, right? Nothing inside. Huh, that's surprising. Yeah. Okay. The other thing I could do is maybe press the arrow, the down arrow in the Git pane. There should be a blue arrow there. You pull first, and then push, and let's see what that does. It may ask you for your username and stuff. Actually, I'm gonna see if I can do. Put it. Let's see. Today. Yeah. We could also try debug that. That's kind of a Git thing. So we can probably debug that one-on-one. It's surprising because PR push is such a simple command that I'm surprised that I mean it's simple in the sense that it takes no arguments or anything, and that's an error that is surprising to me. But we can work on it probably later. So now let's go back to working because that won't stop you from practicing the rest of the lesson. Basically, the idea is to continue refreshing the R syntax. And now that we are here in GitHub document, notice how the document starts. So I have just introduced you to the header, what's called the YAML header, that contains some arguments that give properties to the file. For example, the property title, the property output format, the property author, right? So that makes the file behave in particular ways. So far, it has been very simple, but later we are going to use that to give it more power to our reports. But that is, defined. It's called a YAML header, just a header. Another property of rmarkdown documents in general is this setup chunk. So a setup chunk is generally at it's the very first chunk of a document, and also modifies how the document renders. So the next thing I encourage you to do is to change this comment argument, for example, to something like pound, right? And render the document again by clicking the knit button. When you do that, you should see that the document now outputs with that comment here. So this thing here is the way in which the output that would otherwise go to the console shows up on the output document. So I'm gonna go back to the one that I like, which is this one. I'm gonna render this document again. I forgot to there. So what I'm doing is not necessarily useful. It's useful is to understand that these options here modify how the output behaves at the global level. For example, if I say echo equals true, I get to see the code that lives in each of these chunks, like this one. If I say echo equals false, there is no echo. The code that is there on the console should disappear You see how the output, you can try that yourself depending on how you're overlaying your screens, but if you remove if you change echo from false to from true to false, the output should not show the code that you type, and instead should only show the output, right? So again, the takeaway from here is that there is options that you can change at a global level to make your entire GitHub to your entire rmarkdown document to behave different. Then there is another place where you can also set some options, and that is inside each chunk. So each chunk here has also another place where you first you specify which language you are about to render, and the default is R, so you shouldn't worry too much about that. Then you can or cannot, it's up to you, to choose a label just to identify a chunk uniquely, and it has to be individual, so there cannot be two equal labels. And then any number of chunk options. So the same options that you could feed at a global level, you could also feed at a local level. So I could say that the entire document should produce an echo of the code, but not this particular chunk. So I could say echo equals false. So with that, I should hide this code, right? It's still hidden here in the output, but every other chunk should still echo its code, right? So with this, you have a lot of power to control some options at the global level and some options at the chunk specific level. So I'm going to undo the latest change. So with that, that is another introduction to GitHub Documents. So let's keep moving a little on this document. We are in line 53, and here I noticed a mistake. I was asking a challenge that actually I completed accidentally. So we are in line 53, and the document says that you could use this syntax where the R syntax is so that you call a function. When you perform an action to something, that's called a function, and then you refer to that as calling. You call a function. In this case, you call the function readcsv with parentheses and then arguments to that function. So how do you know how that function works? Okay, you can do in the console, you can do question mark and the name of the function. That would open a help file. Remember that I mentioned that each package comes with functions, help files, and sometimes datasets. And that will explain what the function does. In particular, it will say, well, if this is the function readcsv, then the very first argument to that function is the argument file. So there, the first thing that you have to feed readcsv with is the path to a file. So you could refer to that function this way. But now let me introduce you to another syntax, a syntax that is very common in the tidyverse, which is called the pipe syntax. So basically, that argument that was inside the first argument can be extracted out of the function, moved to the front, and then piped into the function. So if you work with Python, you may think as if it was something like that. So like the object path or like the package path or the object path has the function readcsv. If you don't work with Python, then don't worry. It's just one way to think about this. So for anyone, the first argument to any function could be extracted out and piped into the function with this syntax. So I invite you to run that chunk. What we have just done is we have just read the CSV file that lives inside the path, right? And we have stored the output into this variable called gapminder, right? So next challenge is to view the data in a kind of more natural way. So you could, there you go. So you have, you can print the name of a variable, in this case gapminder, right? And if you just say the name and run that as code, right? If you just play here, what you get is, what I just showed you, that data frame thing, which is a table in this case. And the same thing if you put it in the console. Let me do it here, gapminder. So in the console, it prints a little different than in the document. This is a particular flavor of a data frame, a table with 1,704 rows and 6 columns. Here are the 6 columns. Here are the different types of columns. This is character. This is a double, basically a number, and these other columns as well. So you can see the name of the columns, the type of data, and you can have a glimpse of what that data is. In particular, it is a table prints by default the snapshot of the top left corner of the data set. Notice what happens if I transform this to a data frame. So gapminder, I could wrap it in the function as data frame, and I convert it to a plain vanilla data frame, which is way more boring. So let's do that. Instead, what we are seeing is no longer the top left corner, which is the most useful because it is the one that tells me what are the first name, what are the column names. But instead, I see kind of the tail of the data set, and not even, because then it gets truncated based on some options that you have set globally on your R session. So for the user, the most important difference, generally, it is just this one, the method that the two different things, the two data structures use to print the data to screen. If you have a data frame, generally, what the output that you get is really hard to read. You get kind of lost. You don't even know where these things come from. And if instead if you get a table, you get a lot more informative output. You see the column names, and you see the column types, and the rows. So you also have information about the size of the data. There is other differences, but I'm not going to cover them today because, as Alex mentioned, they are not useful most of the time. Any questions about this? Okay. So here is the little preview. As you can see in rmarkdown documents, you can generate, as I said before, you can express syntax with plain text. For example, we are here in line 74, which talks about the gapminder dataset, and we are here. So see how gapminder becomes like code syntax, and then the rest is just normal text. So that is syntax expressed in Markdown format. Also, you can include images with this particular syntax. So basically, it is a bang symbol, square brackets, parentheses, and then a path that could be an image in your local directory, or in this case, an image that comes from the internet, and that shows like a preview here and renders on the output as you would expect. Showing the difference, Daisy, that said before, I anticipated I would talk about, where you can, that shows the main difference as I perceive it for the user between data frames at the bottom and tables at the top. The tables print the top left side of the data frame, which is generally the most informative one, and a data frame truncates somewhere based on your options and shows you a little bit of information that is generally not that useful. So I recommend. I use a lot tables, and almost never. I use data frames very rarely. So now it's we're getting to the most exciting part of this analysis and almost every analysis. That is the idea of creating visualizations. So we have data, and in tabular format, it's okay. We can digest it with a table, but we don't have a big picture of what's going on. So instead, we can use the plot, which gives a lot of information about the data. So the framework that we're going to use to produce visualizations comes from a package called ggplot2, which is a package from the tidyverse that implements a concept that is called the grammar of graphics. That's a theory that was written in the 70s, someone called Wilkinson, I think. But the thing is that this package took that theory and wrote code so that theory can realize into something that you can use, right? So the beauty of this is that, because it makes sense, because there is a theory behind. Once you understand the basic template, you can produce a great number of visualizations with little effort. All you need to know is where to look for functions that you may want, and then you can express them using that grammar. The basic idea is very simple. So let me make this a little bigger. Basically, you have a data set, right? From each row, you can think of each row as an observation, as a data point, right? And then you represent that point with some kind of geometric representation. It could be a point, it could be a triangle, it could be a line, right? So you need a geometric form to represent your data. It could be a line, it could be a circle, right? That kind of thing. And then you overlay that on a coordinate system. The one that we are more used to is the X and Y, but there's others like the polar system that is like a circle, right? So let's think of this as X and Y. So you overlay the data, the geometric representation of the data and your coordinate system, and what you have, voila, a plot, right? So that is the basic idea of the grammar of graphics. And you can overlay many layers to show different aspects of your data with different geometric representations, so that you are not limited to just one layer. You can overlay layer by layer. So the basic template is super simple. I'm going to zoom in even more. Basically, you start the plot with a function called ggplot, which takes the data set that you're working with. And remember, if you're using the pipe, you could take this out of the function outside here and then pipe it into ggplot. And then you use the symbol plus to add layers. Each layer looks more or less like this: a geometric function, a function that starts with the prefix geom underscore. It could be points, geom points. It could be lines, geom lines. It could be a box plot, geom box plot, and so on and so forth. And then the aesthetic representation. So where on the coordinate system you want to map the data points. So what column you want to plot to X, and what column you want to plot to Y. What column you want to plot to color, and things like that. So all are aesthetics representations of your data, and they go wrapped in this function AS. So this may not make a lot of sense, but it should in a moment, because we're going to make that concrete with one example. So that's the template, and here is what a box plot, for example, looks like. So you take the ggplot function, right? This one here. The data that we're going to be plotting is called gapminder, right? The aesthetic representation. What do we want to put in X? Okay, the challenge is asking us to put, we want to create a box plot of life expectancy for each continent. So actually you can look at the plot at the bottom to see what it's gonna look like. On the X, what we have is continents. So on X, I'm gonna put continent. And on the Y, I'm going to put life expectancy. Notice that, of course, R is very picky about how you type things. If you make a typo, it won't work. And the geometric representation that we want in this case is a box plot, and there is a geom function for that. The geom function that we want is geom box plot, right? So here I type box plot. Okay, let's run that code. And there we have, for each continent, we have represented the life expectancy with a geometric representation that is a box plot, right? As simple as that. So this is a pattern. This is a template that you can reuse to build really large number of plots. So what I recommend you to do, now that you know that the package is called ggplot2, you can just type ggplot. That should take you somewhere that looks like that. ggplot2 tidyverse, you click there. And as any package in the tidyverse, they will have a reference section. So you can look for the reference section there. And you will have all the functions. So if you want to do a box plot, you will have a little picture of what it looks like. So, you know, oh, I want a line plot. Okay, look, you find the line and then you find the function that allows you to do that line. You want a bar. Okay, you find the bars and then you find the geom function that does that. So with the template and with the website ggplot2 reference, you can do an amazingly large number of plots with what you have just learned. So that's pretty powerful. Yeah, good question. Unfortunately, we refer to ggplot2 as ggplot, so that's just like it's like for short. The package name formally is ggplot2, so that's the name of the package. And ggplot2, the package, has a function that is called ggplot. So you do a ggplot will refer to the plot itself, and ggplot2 is the name of the package. So that would be the long story short. There is an even longer story that the package once upon a time was ggplot, but then the author changed it so dramatically that wanted a different name and chose ggplot2. Really? Since, yeah. So takeaways. So I'm gonna render this document. I encourage you to do the same. If you edited something while I was speaking, it should be now captured there. I'm gonna scroll down to the takeaways and see if I missed something. So, takeaways. Yeah. Mm-hmm. Yes, you have. Okay. Did you get any message saying? So it is possible that RStudio needs to install something. When you need, do you get a pop-up message or anything saying, I don't know, install that thing or something? No. Yeah. Surprising. Okay. So here in the wheel thing next to your need button, you have also where to preview, which of these options is set for you from the two of the doc. Does it say previewing window or previewing viewer pane? Okay, choose the one previewing pane. Yes, please. Works? Oh, cool. So this is, yes, go ahead. Mm-hmm. Yeah. Yeah. Excellent question. Yeah. Excellent question. Yeah. Exactly. Yeah. The difference is the same difference that remember the chunks in GitHub documents that we can set one globally and we can set one at the chunk level. Now think of this as a setup chunk and think of this as each chunk. So each layer could have a different X and Y. So in this case, it makes no difference because there is only one layer, this one here. But if you have many layers, if you wanted to do a line, whatever, or points, whatever, then you could set an aesthetic representation here and a different one here. Or, I mean, in this case, I could do something like this. It could be a little repetitive. So I could do this and this, right? So I'm not setting any representation at the global level, but instead I'm setting them at the level of each layer. I forgot to add the plus here because you have to add layers with the plus. Geom point, there is no function called geom point. There you go. So you see how it changed, what it did, it plotted, right? So I'm expressing, in in each layer what to map to X and Y. And sometimes you can do like really weird things. And that's the beauty of the grammar. It's extremely flexible. So by combining layers and aesthetics, you can create, figures that never ever anyone have created before, right? So it's up to your imagination. So I generally start with the geometric representation at the top, because most common than not, you apply the same X and Y's and then you do different things, different representations there. So I start with that, and then only if I have a good reason, I remove it from here and put it within each layer. Both of them are correct. So let me clean this up. So takeaways. When you import data in an rmarkdown document, create safe paths with the here package. It will allow you to move your document around your project and continue to work. If you don't, then depending on where your project is, it might work, or where your file is relative to the root, it may work or it may break. You can use readcsv to read CSV files. It comes from a package called readr from the tidyverse. There's other CSV functions that are less powerful, like read.csv comes with base R. I don't recommend it. How to visualize data? The framework in the tidyverse is called ggplot2. You create every plot with a template that, sorry, actually, I promised I was gonna be using this side of the screen, so let's do that. So you create a visualization with a template that looks like this, and you can adapt this template by simply by looking at functions in the tidyverse ggplot2 page in the reference section, and doing whatever your brain wants to do. How to communicate your science? Well, GitHub documents are amazing, because when you use them, your documents, you can go to GitHub, and each document in MD becomes a web page. So let me show you as an example. Let's go to the R folder. Let's see the rendered version of the document we are looking at now, the skateboard U. So when you go to GitHub, this is what you get. Basically a web page for your data science. Amazing, including figures, including your plots and everything. And you did very little effort. You didn't need to set up anything. You didn't need to work with HTML or anything. So GitHub documents are awesome, because combined with GitHub, they give you a lot for free. And other stuff. Okay, the tidyverse is a meta package. So when you do library tidyverse, you get a lot of functions that live in the tidyverse. You get actually many packages. And actually something that I didn't focus a lot, but when you go to the first part of the document, you will see that when we attach when we run library tidyverse, all of this happened. So there is ggplot2, there is table, there is tidyr, there is readr, pour, dplyr, stringr, forecast. All of these packages became available to you. And that's useful, because usually you need those names to Google things, right? So, with those names and kind of the idea of what you want to do, you should find a function in the tidyverse that does what you want. And also you see a section that says configs, because, you are not, you can create functions that already exist in the infinite, not infinite, but in the vast number of functions that someone else already created. So for example, the function filter from dplyr overrides the function filter from base R, right? And what overrides what? Well, it's simply in the order of arrival. So the last package, so by default, you start with base R. So when you attach the tidyverse, then the tidyverse overrides base R, right? So each new package overrides something that was before. Yeah, that is it. Okay, that is the end of this section. So how we end this is by creating a commit. So I saved the file, I added a few changes, I go to Git, I see what changed. If you want, you can click on diff, and that will will show you in red what was the state of the file before, and in green what is the state of the file now. As you can see, what I've done here is basically completed filled the blanks. So I'm going to select the two files, the mdiff output and the source code, which is the RMD. I select the two of them and I click the boxes together, and then I do complete or fill the blanks. 15 characters, that's great. Space and nothing to say. It was fun. I create my commit message. I can close this window now. You could push, but I prefer to do it from the console with the function PR push. So I go to the console. There is a keyboard shortcut for that, Control 2. Yeah, and then I do PR push. I run that. Now usethis is doing its magic. It's making sure that every change on the branch is incorporated, that every change in the upstream is incorporated. Everything it's taking care for you. You don't need to know about remote or anything. You already took care of that before. And now, if you want, you can do PR view to go directly to GitHub and have a look and enjoy your PR, right? So you can go to see all the commits that you created, all the commit messages that you wrote. If you have any open conversation with anyone, it could be there, right? The PR is already open, so as I push the commits, which are these special snapshots of Git, are continuously added to the same pull request. So what I'm going to do now is to open the room for questions before we finish for the break. I think it's the last break. And in the meantime, I might be approving some of the PRs that you created. Any questions we have? Great questions. Yeah, perfect. That's actually, even if you have in here, it's very good to review because it's critical. First, I want to direct you to the TinyDS Readme file, so you can go to the repo, and there is a section that says, this is not just for this workshop, but also I hope that the materials that we are developing for the workshop will help you in the future as a reference. So there is a section that says how to work with usethis that explains the different functions that are most useful for working with pull requests, and then how we are working on each task today. But particularly the section how to work with usethis might be a good reference for the future. Basically, it says that, for example, I'm now on a branch that refers to this particular task, and I would like to start the new branch for the second task. How do I do that? Okay, I do PR pause. That will move me from, I'm saying yes because that's closing a file that was open and it didn't exist in master, it only existed on the branch, the pull request branch. So PR pause takes you back to master, to the main line of development, and also pushes any changes that come from the upstream repository that might have happened while we were doing other things, right? So now we are, as you can see here, on the master branch here, before we were on this other branch called skateboard model. So now pause brought us back to master. And now to initialize a new pull request to get ready for the second challenge, and actually you can do this if you want, I do PR init, and it does take an argument. It needs the name of the pull request, and the next challenge is going to be called, let's go to R02 scooter. So I'm gonna do 02. You could do any name, it's just that I'm choosing a convention. I'm going to give the names of the PRs, the same name of the file that I'm touching. So the PR is going to be called 02 scooter underscore Mauro. And that's all you need to do. So now if you look at the Git pane, you should now be on the scooter branch, right? And we are ready to start changing that file. Do we have more questions or comments? Actually, as we are here, I encourage people to do what I just did, because the next lesson, actually it's the last one too, of today, we are going to be working with that file scooter. So First, initialize the pull request as I just did, PR init. So first PR pause to go back to master. Then PR init to initialize a new pull request. And then what I'm going to show next, which is the idea of, we are going to, as usual, as I described in that README, we are going to create a copy of the file that we are going to work with. So find the file 0, and that's something that you missed, Daisy, so this is new for you. Find the file that is the purpose of the next challenge. You can click there on that box to say that you want to work with that. And then what you do is you create a copy. So what we're going to do here, we go to the wheel and say copy. That gives us a default name, but the name that we want is probably the one that removes the prefix copy off. And then we add your name there. So I'm going to say 02_scooter_Mauro. And I'm going to say, okay, the file we want to change is the one is RMD. And now that file appears as a file that you didn't know anything about on the Git pane, right? So question mark, Git is saying, look, I can't put this on the stage because I don't know anything about this file. If you want to track it, do something about it. Add it to the stage. Then you click that box and the file jumps on the stage and then you're ready to take a snapshot. And then we do it. We take the snapshot, we click commit. Here is the file, and I can say something like initialize PR for scooter PR space looking for today point, and I create a commit. With that, again, as usual, I can close this and I can already PR push. Even if I haven't worked on this yet, it is useful because I forgot to write the parentheses. If you forget the parentheses, what you get is the source code of the function, which is useful to know, right? So sometimes you wonder how the function does what it does, and then you can just call the name of the function without parentheses. So in this case, this function PR push is going to send this pull request to GitHub, right? I'm going to initialize this pull request and maybe start the conversation with the maintainers of the package. Everything looks good. The subject line appears as the subject of the PR, and the body that I wrote in the commit message appears here as well. I hit create pull request, and there it is. So if I click now on pull request, there is a bunch of pull requests. There is all the skateboard pull requests that you created that will probably start merging in the break, and also the scooter PR that I have just created. So soon, I'm expecting to see some scooter PRs from you. So we still have 3 more minutes. I'm going to open for questions, and if there is none, I'm going to show how I merge a PR and what you can do to finalize a PR that you have been working on. Mm-hmm. Yes. So you mean, so okay, you are now in the new PR that is the scooter PR, and the file. Exactly. So the use this way is you do PR pause. That takes you back to master. And then you click here the pull request that you want. So here I have all the pull requests on the menu, or even without the pause. Just that the pause is nice because it makes sure that at this point in time you synchronize your current work with whatever is happening on GitHub. So the sooner you do it, the better. But basically with the menu, you go from one to the other. Yeah. And soon when I merge the PR that you submitted, it will become part of everyone's repository, right? So now when I merge your PR, everyone will have a Laura. So after they synchronize, everyone will have a Laura skateboard and a Daisy skateboard and so on. I'm gonna show that either now if there's time or after we come from the break. But first, let me see if there's any other question now. No? Okay, so let's do that. I'm going to jump to another window because here, let me hide this behind that. Okay, so here I'm on Chrome logged in as the user that has created this repository, so I have the power to merge pull requests. So I'm going to go to the pull requests, and I'm going to go to Laura's skateboard, and I click on that PR. I'm gonna go here to the files, have a quick look. I mean, in reality, I would have more than a quick look. You know, like I see that she already added Laura, so thanks for that. Thanks. I do start a review, and now my comment is pending. I'm going to add comments on the PR and then finish my review clicking here. So she addressed that one comment. I asked her to add the author and she did. So I'm going to resolve the conversation. That's done. And then I keep moving. Everything looks good. Everything looks good. Everything looks good. Everything looks good. Perfect. So I view the first file. The second file is the output, so I don't need to view it that much. And this one here, the third one, is also an output. It's a PNG file generated by the rendering process. So I can just finish my review and say, congratulations. Approve this pull request, submit my review. She should get an email saying that Maura has approved her pull request, and here I see the commits that she did, and now I'm going to merge this pull request. So the way I like merging pull requests is squash merging. So these two commits that she committed, I'm going to squash them into one. Squash and merge. Each of the commits becomes a dot point here. That explains I'm gonna fix that, included author. Yeah, that's it. So that all looks good to me. There you go. I'm going to confirm the pull request. Oh, and we are already a little over time. So that is the process of merging the pull request. If I go back to the main repository, now the main repository already includes, if I view the code, already if I go to R, it should have a Laura file. So there is a skateboard, blah, 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 skateboard Laura here at the bottom. You see? So everyone now that is in their own projects could now, if you are in pretty much wherever you are, I think, you just run PR. I think this is one that I forgot to document in the README. You can do PR pulse upstream or PR sync, and any of the two should synchronize what there is in the main repo with what you have here, and that should bring her file here. So as you can see now in my project, I have Laura's file. And how did that happen? Via the triangle that we saw before, right? So it happened because Laura from her project pushed to GitHub, then submitted a pull request, and then the pull request was accepted, incorporated in the main branch, and now everyone is pulling from that upstream into their own repo. So now that work has been distributed across the repositories of everyone in the organization. So that is the magic of collaborating with GitHub. Okay, so we have about 10 minutes break. See you at the top of the hour for the last session of today. Yes. Mm-hmm. Perfect. I really appreciate you here. You are an excellent member of this workshop because you have experience in other languages by knowing R, and by seeing you do it, like you have accomplished the whole challenge, including GitHub and all the things. So that demonstrates that it's very doable. So everyone who works in R should also be able to do what you just did. and the next session is going to be recorded, so you can catch up with that. And if you miss it, that's fine. Probably tomorrow you should be able to catch up as well. So yeah, that's it. Thank you very much, Laura. I really appreciate that you're here. Cool. Bye. Okay, little break and see you at the top of the hour, right?